of where I'm coming from and what I'm going to be going through today. Who the hell am I? Why am I talking here today? So I've been working in the data industry for almost 2 decades. I've worked in Europe. I've been in Australia for the last 8-9 years. I've worked at places like Qantas, Telstra. I love machines, as you can see. That's one of the jet engines at Qantas. I lecture in AI, both at MIT in the US and also Texas University as well. I have a fellowship. I like to call myself a data-driven dad. And I've also self-proclaimed emerging tech futurist, whatever the hell that job title means. So today, I'm going to make it a bit more lecture style, considering we've got a bit of time. Normally these talks go for like 20, 30 minutes. We never get to the meat of stuff. So there's like 3 things I'm going to cover. We call them learning outcomes. Again, we're not going back to school, so don't worry. But we'll cover off introduction to large language models. We'll do a bit of an engineering fundamentals around what prompt engineering actually is. And then I'll run through some super helicopter concepts, use cases, but we'll actually do like live demonstrations essentially. So to sort of step back, before we can actually talk to these machines and sort of explain what we're trying to do and get better outcomes, we need to have a better understanding like how these machines actually work. So I'm not going to go through some crazy mathematics. I'm just going to help you understand like conceptually how these work. And I apologize if anyone in the room already understands some of these aspects, but I think just that little bit of extra context at the start is going to add a lot of context for everyone else. So large language models are essentially trained using what we call language modeling techniques. And that is essentially to predict the next word in a sequence. I try to make these a bit funny. So that burger was dope. Overall, it was either positive, negative, or like absolute fire, right? And when they get trained, millions and millions of content, books, Wikipedia goes through these machines and they're hiding words. They're literally hiding the words and they're hoping the machines can get really good at guessing the words. And by doing so, through that guessing process, they try to understand language. So if we take that example, we've got a ground truth. We know what the actual text is, but we're hiding stuff and we're trying to push the machine to get to a point where it can make those predictions. So essentially it's predicting word by word. And if we take another example of this, so if I take something much larger, and again, I did this, so I asked it to create a Five Guys review. The burger was dope, the beef was juicy, perfectly cooked, toppings were fresh, bun was toasted golden brown, every bite was a blend of flavors, just melted. Service was quick, friendly, and just pure, and then maybe the last word happens to be bliss. And the way it derived bliss, so you see at the corner, you see these like P 0.02, 0.008, 0.3, 0.78. These are essentially like predictions. So these are percentages. So 2%, 0.008%, 3%, 78%. So as it's going through the words, it's predicting word by word. And as you type, if you use a ChatGPT, you'll see it spitting out word by word. It's predicting the next likely word with some level of probability, and it's picking the best word. And you'll see that I've highlighted some words in yellow. And those yellow elements are some elements that it's looking at the text and it's going, actually, it's talking about dope, perfectly, just melted, quick, friendly. Maybe I'm going to pick bliss because I think those combination of words help me understand that context. So it will go word by word. It might predict the next sentence. It might predict the full stop. And then it might predict the end. And that's how you essentially see that process come together. And I'll show you some examples a little later when we put some things into ChatGPT. There's ways that we can actually surface those probabilities. So you'll be able to see actually like the mechanics behind the scenes. So essentially it goes with that, then it predicts burger, then it predicts word, then it predicts dope, and it has this vocabulary. And the vocabulary can be literally every word in the dictionary, words, letters, numbers, symbols. If it's multilingual, it might have Japanese characters and some Chinese characters and things like that, but it has that within its context. And as it rolls through, it will predict word by word and it will sort of go through that process. And we say that's during inference. So if you're not from machine learning, artificial intelligence, you might have heard the word inference. And inference essentially means that I have a machine, like a software program, and it's loaded up, and it's like, I'm now hitting go on that program. I want you to boot up, and I want you to do a job. It's like, I'm going to pass a job to you to do. And we call that process inference. It's like when we tell the machine to go and make a prediction, that process is called inference. So I talked about like super high level. We're pumping lots and lots of content through. We're creating these models. A lot of these models, like the GPTs, like the early ones, like GPT-2 and some of these other ones, they're not new. They've been around the last few years. It's only around 2020 that GPT-3 came out. And that model essentially was like the initial starting point of what we all know as sort of ChatGPT, and that was in 2020. But a lot of you might have only started using something that you now know as ChatGPT in 2022. So the models were available, but what was missing was that these models were only trained in language. They were really good at understanding, generally comprehending language, but they just weren't that perfect for like having conversations with. And essentially what they did, the next step they did is, once these models were trained really good at understanding language, they decided actually what we're going to do next is train them in having conversations. And you might think the two are the same, but they're not quite the same, because what they were trying to do is, okay, you can generate content, but you're giving me absolute garbage. If I give you an instruction, is what they like to call it, an instruction, like a question, like what's the capital of Paris? You don't want it to, what was the capital of France? You don't want it to just respond with Paris. You might want it to say, the capital of France is Paris. Like, it's a more conversational aspect. So these were called like instruction models. And these were essentially the same language models, but they went through a process to fine tune them. And that's like basically, you know, I've got a child now, Otto, he can brush his teeth, he can do everything else. Maybe I'm going to get him to get his bed ready. I'm going to give him some extra skills so that he can act on himself. And that's what happened in 2022 with the Instruct version of GPT that came out. And that was essentially the model that was powering what we all know as ChatGPT. And then subsequently after that, a plethora of other models essentially started to come out as well. So some of the steps that essentially occur, so that process that I talked about, and I'm not going to go crazy into detail here given some of the audience may not be quite technical, but we start with this process of like a large corpus of data. And when I mean large corpus of data, I mean like everything on Wikipedia, everything on news websites, like billions and billions of websites and URLs. And these are like absolutely huge. So for example, one of them is called Common Crawl, is it overview? It's one of these, sorry, I thought I prepared this. Always the way. So Common Crawl is like one of the largest data sets that actually get used. And this is like a public sort of repository that's been pulled together of like all of the stuff on the internet essentially. It gets updated month by month. And that's what essentially feeds a lot of the stuff that you see in ChatGPT and others, and a lot of the other large language models. There's other data sets they use. They don't all publicly tell you what they use, but you can see here like Wikipedia they've used. There's like 6.1 million pages. There's Yahoo, there's Stack Exchange, there's NASA, there's millions of pages of content in here. Like, so they go through that process of masking and reading through all these reams and reams and reams and reams of text. And essentially that pre-training process is what gives us this foundational model. So there are some models that are available that you may have heard of that are open source, which are like publicly available. You can download them, you can run them on your own hardware, but those are essentially what we call foundational models. So those are really good at language, but nothing really else. The next step they go from there is we get curated prompts. So we give lots of instructions and we have an output. And that could be, I want to do a chat conversation. I want to go and have lots of conversations, question, answer. And I want to train this model to have conversations or instructions, right? Same way there's other models that have come out that people have taken these large language models, these foundation models, and trained them to do other things like work in finance or solve problems with health. But essentially that's the process you go through. And then the last step, which is only really done by large organizations like OpenAI that build things like GPT-4 and Google and those other guys, is a process called reinforcement learning with human feedback. The main component here to sort of watch out for is this aspect of what we call like human feedback. So essentially, if you've ever used a ChatGPT, sometimes you notice it might give you like an A and a B, or it might ask you for a thumbs up or a thumbs down. That data gets collected, and then that data that gets used to then go, actually, we're going to fine tune it even further to go, actually, what's good, what's bad. And a lot of this actually might be about quality. It's actually less about quality, and it's more about things like illegal activities, profanity, hallucinations, anything that just they don't want to happen in the machine. They'll force it, they'll ask it questions about things that it maybe shouldn't talk about, and then they'll force it to do things and not do things, and sort of train it essentially through that repetitive process. So in my case, it's like me bribing my child with chocolate at the end to make sure he sticks to what he needs to do. And then the output of that final step is like these ChatGPT models that have gone through all these steps. But you can access these models here, these foundational models, open source. But if you go to the big models that like the OpenAIs and like GPT-4 or Anthropic, Claude, Google Gemini, they tend to have gone through all of this whole entire process. And that's what differentiates them. So they've gone through a lot of this process of training and fine-tuning and validating and making sure that these things behave as we would expect them to. So one of the things that we then have to do, let's just say in this case, we've now received our model. We have this model, right? We've essentially built this model. I'm Google, I'm whomever. I've built this language model. It's trained, it's really good at conversation. And what do I go from here? So what we need now is something called hosting. We need a machine to put this on, right? Like at the end of the day, like this code, it's just like an application. It's like a photo on your device. It's not going to do anything. We need to actually put it somewhere so we can run this. Now, the problem with a lot of these models is given the extreme size of them, like they're very hard to run. So for example, a top-end MacBook M3 that I've got here with like 64 gigs of RAM probably can't run like a GPT-4 model. But maybe the small open source models it can because of the size. So dedicated hardware is a concern. So that's why you end up paying a cloud provider that has a monthly subscription to use them. And then the second one is there's a what we call a token rate limit, and that's essentially, we'll get to tokens in a little bit, but these are like the input and the output limitations. And what you'll find is, depending on the hardware that you have and the size of the model that you have, you're going to be constrained to how much data we can put in, how much data we can put out, and the volume of users. So if I ran a model like that on my laptop, it's only going to be me using it at a snail's pace. Versus if I had massive amounts of compute, I might be able to run maybe thousands and hundreds of thousands of users. And at that point, you have a deployed model. And the important factor with this is a lot of people in organizations, especially enterprise, will go, oh, I just want to grab this large language model and do our own thing, and we'll run it on our own servers, and everything will be great. But it's actually not great. I think a lot of times people don't actually consider the compute. And given the fact that everyone is trying to do this AI stuff, the dedicated compute required, if you were to purchase this hardware, it's next to impossible to get your hands on. It's like a black market essentially for some of this stuff at the moment. Yeah. So we've got the model, but now we've got to feed the input in. So, we've got that input from before, that burger was dope. You'd think that model would just feed it in. I'll just feed that text in. But actually another step occurs here, and that step is what we call tokenization. And what this is like, the models have a dictionary. Imagine every word in the dictionary was numbered 1, 2, 3, 4, 5. As you go down a list, the models don't understand language, they understand numbers. So we feed numbers into them. And what we do is we take these words and we tokenize them. So we say that might be a 2, this might be a 4, and we feed these numbers into the machine. And this is important because tokens aren't always just words. Sometimes a space can be a token, a new line is a token, a full stop is a token. And each of these tokens is essentially how you get charged for these models. So more tokens, the longer it takes a machine to calculate it. So you get charged essentially your usage on these products by tokens. So if I'm using a ChatGPT, I'm paying monthly, you don't see this. But if I'm a business and I want to build a product on top of their services, on top of these models, I'm going to be charged by these tokens. So you'll be seeing pricing that's on a sort of token by token basis. So if I go to an example here, for example, grab the text here, mark that here. So you can see here, it's got these tokens. And other things that they've done as well, depending on the word, I'm just trying to find an example. I'll put tokenization at the end. some words are actually split into two, because that word "ization" is actually used so frequently that they actually break them into tokens as well. So again, that text gets converted, and it just gets converted essentially into all these numbers. And then there's a dictionary that the machine actually looks at and pulls these in. So other models that have images and things like that, there's a similar process that happens, but with words, this is the same thing. So a lot of people ask me like, hey Vincent, I'm paying an arm and a leg for my large language model usage for my enterprise. Why is that? Or I'm writing something with a prompt and it's taking forever to calculate and slow. A lot of that comes down to this process, because the more we have to feed into these machines, the more they have to calculate. And the same way, the more they have to output, the more tokens they have to output. So that process, the only thing that they can tangibly price us on that's directly a relationship to their cost for these providers is tokens, and therefore a lot of the pricing you'll see will be based around tokens. Another thing to also watch out for, and I like to say this sometimes because we live in a diverse world, so I'll go to Google Translate. Let's go Japanese. So you notice here that we're at 60 tokens, but if I was to drop that in, although the text is less, the tokens are much higher. Because what's happening here is that each symbol is actually like multiple tokens stacked together. So if you're dealing with anything that's like non-English, it starts to go through the roof. If you're dealing with like pasting code into one of these, like I'm going to just shovel my JavaScript code and get it to help it understand, or whatever, like anything that's like non-Latin based English, you'll see things like this. I think emojis also come into the same sort of problem as well. The costs start to skyrocket. So, these are little considerations to also think about. So that's like the overview, large language models, the models themselves, the process, and the tokens. Any questions so far before I continue?
In relation to text to video or text to image,
yeah,
would you need a completely different foundation model?
Yeah, depends. So there's two types, and I'll touch on that in a little bit. There's ChatGPT right now as an example with their GPT model. When you give it an image, it converts the image to text, and the text gets fed into the machine essentially. They're not true like multimodal. The other one is like a Google Gemini example, is what we call like multimodal, and it doesn't matter the tokenization step and the model and the output. It's any in and any out. Like you can feed text in, you can get image out. You can feed a video in, you can get text out, video in, image out, that sort of stuff. So like the format essentially doesn't matter. And that's sort of a new thing that's appearing. And we'll start to see potentially open source models in that space appearing. So that will then possibly start to supercharge that process. But yeah, so there's different tokenization process that happens for things like videos and images. So they'll slice them essentially and other things like that. Yeah, patches, yeah. Question at the back?
If you go back a couple of slides, two slides there. Yeah, next one. Yeah.
This one?
Next one. Yeah, this one there. You have mentioned about how the enterprises are deploying this.
Yeah.
Can you give a couple of examples how maybe a large enterprise like telco or else pharma can you give a couple of examples?
So majority of the use case is like everyone's gravitating towards OpenAI. I'll talk about some examples and at a very high level in my next section around different types of models that are available, like other enterprise models that are available. But most people are gravitating towards OpenAI being the only player in the space. Definitely not. There's other types of like enterprise grade models that have this, been fully fine-tuned. You've got like Claude, Gemini, there's Titan by Amazon, there's a few others. But everyone's using that. And the way they're using that is they're accessing it through an API. So you're just going, okay, you keep your model, I'm just going to send my instructions over to you, I'm going to get the instructions back. There's a couple of gotchas with that. The first one is obviously cost is a concern, but the fact that your data is being sent over the internet to somewhere and it's in a black box and you don't know what's going on with it can concern people. So especially if you're in a regulated industry, let's say you're in banking, let's for argument's sake, and you're dealing with APRA and they say, no, all the data has to remain inside of Australia, that becomes a concern, and that's usually the sticking point. So what happens here is like companies like Azure come along and they go, we'll do a deal with Microsoft. We'll get a copy of their model. We won't share it with everyone else, but we can host that in Australia, and we'll make sure there's safeguards so that when you send the data to us, we're not going to then share it for this reinforcement process and things like that, for example. So they'll give you those sort of safeguards. But most enterprises are doing that. Some enterprises, I've seen very rarely in Australia, will then go an even bigger route and actually fine-tune models, either the OpenAI one or the foundational models, and then host them elsewhere. You'll be able to get the slides at the end, so don't get too concerned about taking photos. But that's usually the difference. And a lot of it comes down to cost and quality. The only reason why you're fine-tuning is because maybe you want to teach it to really understand a complex domain problem. So if these models, like for example, we're using ChatGPT, it might not understand Australian law, for example. Might understand American law and British law, but maybe not Australian law. So then I'm thinking, okay, how far can I push it with prompting, which we're going to touch on in a little bit, or do I need to go and do something like supervised fine-tuning and spend a bit of money and teach the model, take the existing model, but now teach it new tricks essentially to behave in a certain way. Any other questions? It's all right, you can ask.
How does the size of the model influence like performance? Like 7B, 70B?
Yeah, so best way to describe them is essentially these models are built in what we call neural networks. And the best example of a neural network in a simple form is like mimicking human brain, right? You've got neurons, you've got synapses, data information passes through. When these models are larger, essentially there's more switches that can be configured. And because there's more switches, there's more space in the brain, so to speak, for it to learn more things. It doesn't mean that the performance is going to be better, but what we have found is there's a point that they've reached with like GPT-4 where it was just like, you know, I don't think they've reached a limit, but it just became no sense to keep going from an accuracy perspective. But there is a huge margin of difference. So there's models that can run on a laptop or on a phone, but you're not going to be able to like create whole entire code bases and solve all your problems, but you might be able to have a conversation with it. So, but there's processes and there's more sort of work being done to make those bigger models smaller, but with the same performance. And there was another point I was going to make about that. It's totally skipped my mind. GPT-4, most people think it's one big model. It's actually like multiple GPT-3 size models like daisy chained together. So they've actually reached a point where I think it doesn't make any more sense for them to go any bigger. They're just optimizing the performance of what they've got now. Any other questions? Cool. Amazing. Prompting. So this is a good quote that I like to say. So nature is written in the language of mathematics. Galileo said this in 1623. There's this concept in, I don't know, let's just say in modern psychology and other aspects that two schools of thought. One is, language is not directly related to our personality and who we are. And there's this other concept in the school of thought that language is our personalities and who we are is essentially encoded in the language that we speak. A good example of this is like take a child who can't speak any language, put them in the middle of nowhere. Like let's say I had a child, he can speak Turkish and English, but if I left them in China for whatever reason, or Indonesia or another country with another language, they'll learn that language without assistance. So there's this idea that there is some encoding that's happening within our language structures. And this is becoming more and more apparent the more that we start to do things like prompting and understanding language models, because the language models have essentially found a way to dial into those personalities and biases and other things without us explicitly telling it those things. Just because of the sheer volume of data and language it's been able to consume, it's been able to figure this stuff out. And that becomes quite important because this tells us that if these models are essentially taking language in as an input and it's doing some mathematical process, there is some optimization to be had with the performance of these machines if we understand that they're just as biased and flawed as we are as humans. So some of the examples that I'm going to show you might look a bit funny and surprising, but won't come as a surprise when you behave that way with other humans.
Is it biased towards English language?
In what sense?
Because of its input of so much English language. Is it biased in terms of prompting?
It can be, yes. Yeah. So, for example, there's one provider called Mistral, which is based in France, which is heavily weighted on European languages. So it's got better performance. There was another recent one. It's called Aya. I can't remember who built that one. Really big, but it's based on like Latin and lots of other types of languages. So it's better at things like Turkish and Arabic and things like that. So yeah, so English is fine, but a lot of countries are now investing in problems like this because they want to make sure that their language and their culture is represented fairly in these models. So the key with all of this is like with the use of natural human language, we can generate lots. We can generate text to text. So you got your GPT, there's Claude, there's Google, which they first called Palm, then Bard, then Gemini for whatever reason. Amazon Bedrock, the list goes on. There's Mistral as well, which is a new competitor in the space. There's text to visual, so DALL-E, and then I think Sora's coming out with video, Midjourney, Runway. And visual generation, I'm talking, is not just video. It's 3D models, it's like image with depth, like all sorts of stuff now. I've even seen like dance choreography and movement being generated. We've got text to audio, AudioCraft, 11 Labs, Stable Audio, and there's like hundreds more. Like this space is like absolutely exploding because the technology is becoming more easier to access and more widely understood. And the method of that learning process can be applied to most modalities. So like image, video, genetic data, whatever you want to try and help it understand. Like the coolest one I've seen is NASA have done one where they use it to generate new like structures for things, and they just look like crazy like this, but like it can hold 30, 40 times more weight with like half the amount of mass. And they're using these and they're trying to train them to come up with new things. I think Google DeepMind did one for like coming up with maths problems and solving maths problems, for example. So this is just going to keep exploding, essentially. And the key to all of these, you know, there's text to code. The key to all of this is the prompt. It's the instruction. You know, essentially these things, as we've gone through this process, they work based on instruction. And the instruction is through natural language. So we're interacting with these machines, with these models, through the exercise of the instruction. And I've put English there for argument's sake. For me, it's obviously English, but for others, it could be other things. If you're coding, you might throw in code, but essentially there's some form of human representation or human language. In multimodal models, if it's audio, maybe you talk to it. It's audio-based, but essentially we go from language as the instruction into these models to make predictions. But we've got the instruction, which I'll touch on, and we have the engineering part. So when we talk about this process, we've got prompt engineering is a process that's been sort of toyed around, and that term's been floating around. And it's the combination of the prompt, which is the instruction, and the engineering part where we're trying to engineer and build some output. So when you bring the two together, it's essentially the iterative process to drive a specific output. So when we talk about prompt engineering, we're trying to use all these models that we're talking about, text to text and vice versa, to behave in a really certain way. So it could be we want to create, I don't know, images that look a certain way. If you haven't noticed, all my images are based on, created out of an image generation model and come out in a certain way, right? I've prompt engineered that process so that I consistently get the same output exactly for the problem that I'm trying to solve. So through the means of prompt engineering, we're getting better at sort of engineering the instructions, essentially, so to speak. Language, the instruction, and then that goes to a large language model like a GPT-4, for example. So let's start with a typical prompting scenario. So now I'm going to start to actually build things up here, right? We've got Otto. He likes to do bedtime stories. Let's just say I want to create a movie scene for him and a story that we can go with, right? And you might put something like, give me a movie opening. I don't know, like everyone here who's actually used ChatGPT might have just put one sentence input in and gone, it's garbage, I'm going to toss it in the bin, it's hallucinating, doesn't mean anything. But like, would you talk to someone else who you've hired to work for you? Would you give them 3 words? I mean, if they knew you, yes, but if they didn't know you and they're a total stranger, or they're a child that can't understand half of what you're telling them, would you ever tell them a couple of words and expect them to actually understand what you're saying? Probably not. So in this case, if you said something like that, we'll get God knows what. Like, I'm happy to give this a try, but it's not going to be what we're looking for, right? It's going to be totally off script. So what we can do, and again, I'm going to share these with you all, is we can use some sort of prompting framework, so to speak. And a lot of this comes back to like just simple human understanding of behavior. You've got a 3-year-old child, if you can't fathom that in your mind and you don't have kids, think of a random person off the street. You literally go outside and you get a random person off the street and you're expecting them to do something for you. You can't expect them to perform properly if they have no idea who they are, what the context is, what you're expecting of them, what's the output and the format. So I'll share this at the end and we'll walk through some examples together. But you can follow this sequence or these questions essentially as a way. I almost think of them as like a job description, right? Like when you give someone a job, you kind of have a description of what their role is, what they're expected to do, what they're not expected to do. Maybe you onboard them with some examples and essentially start to bring this together. So we think about who, we want them to simulate a person, a persona, a personality maybe. The what could be things like as much background, past examples, what is the actual request. When we think about the steps, talk through it. It's like sometimes some people like a very specific thing to be done in a certain way. We'll just go, if I want you to generate a movie opening, maybe think about the movie ideas, then think about the characters, and then think about writing the script. So you kind of step by step, we call that chain of thought. We break down the thought process and we help make sure that it understood the thought process. Why? Why on earth is it doing it? Because if I wanted to get rich or if I wanted to just tell my kid a story, context is critical. And the last one is output format. So a lot of people here might be writing emails, might be writing their LinkedIn posts with the generative AI agents, but you haven't told it how many characters. Do you want to use emojis or not? What sort of tone do you want to use? What's the output essentially? So we can bring this together essentially to form a bit of a basis of the type of prompting that we want to use to make sure that we get consistent content. And so the example I ran through here was you're a top movie director with a focus on indie movies, winning film festivals. We're trying to launch a new short movie for an upcoming movie festival. Again, movie festival. The tasks are, I need you to help me with the intro opening. Think about the script style and location. So I've told it to be quite specific. The goal is we're trying to launch a new short movie for that movie festival, and the output format is I need you to generate a storyboard using the hand-drawn style for the opening scene, intro using DALL-E. And by saying use DALL-E, ChatGPT knows to go and create an image for me. So instead of giving me the script, I said I specifically want storyboard images. So you can see on the right-hand side, it's created a movie called Crossword. It's in Paris. There's a young gentleman. There's a whole story behind this, right? It's actually built this nice creative story for me. And I was like, actually, this looks pretty interesting. I might be intrigued by this. And now I've got something I can work with. It sort of helps me actually really tangibly anchor the model to create an output that I'm looking for. And again, this could be for anything. It doesn't have to be visual. It could be planning a Christmas party. It could be, solving the world's problems. But the beauty here now is we can start to swap out any component. So I'm keeping the context, the task, the goal, and most of the concepts the same. But instead of the role, I'm changing the role. I'm now saying, you're a top website designer. Can you draft me on the output format as well? Can you give me an output of an image of a website? Another one I said for merchandising, I probably shouldn't say this because it's being recorded, but I said, you're a top merchandising designer for Disney. Disney's regarded as some of the best sort of merchandising because of their, all their licensing and everything they do. And it sort of took on that idea that, okay, I work for a branded experience, I'm creating merch. And it created all this amazing crossword style pins and the guy here even with the little French haircut thing and the video, it's just nuts. Just because I've been able to give it as much context, every prompt I'm doing now, it's coming up with a really consistent output of what I'm looking for, which is key. And then on top of this, we can start to change any component of this. So we could say actually website designer, merchandiser, software engineer, tax accountant. I've actually built a hush-hush version of a tax accountant GPT that gives you the real tax advice that you want. Just by, creative prompting, please use hypotheticals and give me scenarios to talk about, actually quite interesting. Context, is there any history there? Objectives. What does success look like for you as well in this case? Is it you're doing this to get a raise? You're doing this to solve a particular problem? Goals could be, I want to be rich. Why not? Help me get rich. Maybe you want user stories. So if you work in product team, maybe you want the output to be like Jira tickets that you can just slap straight into Jira. Same thing, but you're just telling it like what the expectation is, and it's going to start to change it. Prototype, you might even ask it to create a machine learning model for you. It's not going to be perfect, but it will write some dummy data, sklearn, it will spit out some Python code for you as well, which would be interesting. We can do images, like I've shown you. We could do long form. We could do text for blog. We can do code, JSON format. We can say, hey, give me a spreadsheet of this stuff. So if I said the movie stuff, but I said, hey, I want you to write the movie scenes and give it to me in a table format in a CSV, it'll spit it out. So if that's something that I want and I can send to someone else for another task, it's like ready for me. I don't have to take the output out of the ML, out of the large language model, and have to manipulate it in order to make it work for me. It's ready for the context and ready for what I need it to be. So going back to that, the nature is written in the language of mathematics. We encode our behaviors in our use of language. I remember I mentioned this to you before. So we've got our framework. It's going really well. But what else can we do? Well, we can encourage people. This one surprisingly works really, really well. So if you say to someone in real life, I'll tip you $200 for a good job, most people are going to be pretty positive and perform in a really good way. Research shows that if you do this in a large language model, it improves the performance by a few basis points. Surprise, surprise. Weird. And a lot of this comes back to the same bias of human behavior and that encoding that essentially these models have somehow picked up on. Someone's actually tested it. $200 seems to be the sweet spot for this, if you're asking, yeah. Other instructions we could do, we can encourage them even more. We can say, now, actually, your job and mine depends on a good outcome. So now, I'm going to get fired, you're going to get fired if it's totally crap. So we want to make sure that, you do an absolute stellar job. And again, similar to the one previously, it improves it just that little bit more as well. And then lastly, a really key one with hallucinations is, well, it thinks it needs to perform really well, so it goes and performs really well. But actually, if you tell it, if you don't know something, say that you don't know, actually reduces the risk of hallucination quite a lot, because it's not trying to fumble and guess and because its primary purpose is to answer your question, which is doing as much as it can do. But if you're saying you don't know, just tell me you don't know, it actually changes its behavior. In some cases, it might tell you. In some areas, it's unsure, it's not comfortable with, and that will actually help you as well. Because in some cases, you're going to be like, oh my God, what on earth is this going about? It's not going to completely get rid of hallucination. That's always going to be a problem, but it's going to help you at least mitigate some of that risk as well. So I talked about the prompt, the instruction. There's another component, which is the engineering. And this bit's a little bit technical, but I think it's worthwhile just showing some examples as we go through it as well. So what a lot of people don't realize when you use something like ChatGPT is there's what we call a system prompt and a user prompt. So what's essentially happening here, and parameters, which I'll get to in a second. So there's a large language model. Say this is GPT. I'm doing the best I can with trackpad. GPT-4 model. And then outside of this is like ChatGPT, right? And in here is a system prompt that literally sits on top of this that says, actually, you're going to behave in a certain way. And then your prompt comes in on top of that. So that's why when you ask it to do certain things, it's like, actually, that's totally illegal. I can't do that. So it's like its original instructions that have been given, and what it can and can't do has been sort of innately sort of drilled into it. So if I show you an example of what that looks like.
You can't write in the style of a different author now, right?
Yeah, can. You just got to be creative with the words, how you prompt it. So the system prompts have been leaked, and the way they've been leaked is they carefully crafted messages to tell it what its previous instructions were. And this isn't really a secret, there's ways of doing this. So some of the different ones, like ChatGPT, for example, there's things like, some of their system prompts are like, you're a large language model, you don't have personal feelings. And you ask it things and it says, I don't have any personal feelings, I can't help you. I can't give you personalized medical or legal advice. That's a good one. You know, you want to go, you don't want to pay for a doctor. Why would you do that? So a lot of these are like the instructions. These are the system prompts. So when you're trying to prompt it with something else, it's kind of contradicting this. So then this is just essentially overriding it. And that's why a lot of cases, it's not quite behaving the way it is.
Can't you get around that?
You can.
Yeah.
By just saying, imagine that you,
You can.
like Dan, that do
Yes,
anything.
Dan.
There's Dan. Or if you're actually using the model directly, you're not using ChatGPT, because ChatGPT has got its own system prompt of how it should behave, but you can use the model directly. So in this case, I can do a system prompt like, you are a sentiment analysis tool and you will respond with positive, negative, based on user input. Sorry, so the user says, I love burgers. Who doesn't love burgers? Positive. That's all it's going to say, because that's all I've told it to say, right? If I'm a bank, for example, and I go, you are a... Can someone shout out a random brand name? Is anyone creative here? Sorry? Lacoste. Okay. For a bank called Lacoste, you're a helpful assistant. You're a helpful chat assistant for a bank called Lacoste, and you will give general advice. Right? So if I say, tell me about credit cards, and I could be like, actually, use formal language, keep it short and simple. If we say that again, it's short and simple, right? But then I go, actually, tell me about JP Morgan credit cards, because that's what people like to do with chatbots these days. Ted talks about a competitor, and now I'm like, oh my god, I've got a chatbot on my website for my brand, and now it's giving me advice about competitors. What the hell's going on here? So then you're going to be like, actually, like let's tune. And this, you can see why OpenAI's list is so long. Like, don't talk about illegal stuff. Don't talk about this. Don't talk about that. So you like, actually, keep it short and simple. Do not speak about any other brands other than Lacoste, or just give general advice. You can say, I'm not allowed to talk about other banking providers. Again, I'm just doing this live, so it never always behaves the way you want it to live, but I'm not allowed to talk about any other banking providers. How can I assist you? So like that's essentially how the system prompt and the user prompt work. So you can use all that same prompting techniques to construct system prompts. If you've got the paid version of ChatGPT, you can create like what's known as custom GPTs, and essentially there you're giving it a system prompt. It's behaving in a certain way. So you can sort of do essentially the same thing. This is the API if you're using the API. This is how it works. If you're ever coding and you're using large language models, you'll have a system prompt and then you'd have the user prompt. So again, it works in a very similar way.
So they basically build the model, and then after the model's built, like Sora now,
Yep.
then they do all the system
Correct.
after that.
Yeah.
Make sure that there's no...
That's right. So if I show you an example of another one, I want to show you the iOS one. So if you use the phone, oh no, it's not the full thing, but it will say things like, you should use a few sentences only. So if you ever use the voice one, or if you use the phone one, the output actually volume is different, the quality is different, because it's actually behaving for the device that you're on as well. So they've done different system prompts based on the device and the use case as well.
Does the system prompt come before or after the user prompt?
Before, always, yeah.
Is there a reason for that?
Essentially, you're starting up the model in a certain behavior, if that makes sense, and then it's waiting to receive instructions. So you've got the system prompt, you've got the user prompt, and then we have something called parameters. And I'll touch on this briefly, but it's an interesting one to understand as a concept, especially since I'm spending the time to go through it. And parameters, if you've done any sort of machine learning, is like, if you can buy a stock car off the street, or you can go to a dealership or your friend who loves to tweak cars, and you can tune it to behave in a certain way. Parameters essentially work in the same way, and there's specific parameters that come with these language models, and we can change them. But we've done the prompting, we can get so much with prompting, and the parameter part will just like supercharge it essentially by forcing this to behave in a different way as well. And the key parameters we have, so we talked about prompting, so that's the sort of the prompt structure. Whoa. The other one is like these parameters, and like some of these are obvious. So max tokens is what you would imagine, right? So we've got tokens, we've got input, and it makes a prediction and it makes an output. And you'll only access these if you use the API, so if you're building your own services on top of these large language models. But max tokens would be good where you're worried about cost, right? If you're asking it really simple things and you're asking for a few sentence summaries, if your tokens are mostly 400, maybe you'll set the max token to 600, because at one point it might have had an update and it suddenly starts spitting out all sorts of garbage, and you're going to get absolutely stung for the cost of that. So max tokens is just like a way of limiting how much it does as a way of sort of controlling the input and the output. Temperature and top P I'll touch on in a little bit. They're interlinked. But frequency penalty is the chance of a token repeating. So imagine there's some output of text that's coming out. There's lots of words or tokens. How much of those words do you want them to repeat? So if you're talking about creating some long form content, how many words are you comfortable with repeating versus, the same words? And then temperature and top P are sort of what we call the creativeness of the model, and you either tweak the temperature or the top P, but I'll show you some examples of what that looks like in a minute. But the higher the temperature, the more randomness you're giving it. You're saying actually be totally random. So if we go back into this example, here, and I'm going to come out of the chat, for example, I'm going to go to the complete one. So this one behaves the same as the sort of the ChatGPT one would work. Write me a poem write me a short story. And you can see on the right hand side there's temperature, there's top P, all that stuff's already been set. Once upon a time, little girl came Lily, da 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 da. No, beautiful story. I'm going to increase the temperature, I'm going to go 1.5. Beatrice, okay, talks about some bunnies, it's cool. Let's increase that a little bit more, 1.73. Kingdom, enchanted forest, teapots, poppy, and then what on earth is it talking about now? It's gone completely random, right? So there's a point where it just completely like loses its mind because you told it to be totally random. But the beauty here as well, I can go the other way. I can bring this temperature all the way down, right? And watch this. Magical forest, lily. Start again. Magical forest, lily. Start again. It's totally the same, or near enough the same every time. It's taking that prompt exactly, and it's not giving it any room to breathe, but behave the way it's been programmed to do so.
And top P is?
Top P is a similar way of doing it, but essentially it's how it samples the words to use. So it's another way of controlling its creativeness, essentially. So the higher the top P, the higher number of random or different tokens that get used. Temperature changes its randomness and creativity, but top P changes its selection of words. And sometimes the two interchangeably can be used, and I'll sort of show you some examples of what that looks like. So when we think about different use cases, and again, this is not extensive by any means, but if we're generating code, we want low temperature, low top P, because we want it to stick to established patterns and conventions, we want it to be deterministic focused, we want it to be correct, essentially, as much as we can. But if you're doing something like creative writing, you want to increase these a little bit, right? Because you want it to have a bit more diversity and exploratory. Chatbot, you might want something different. And then, same with different use cases. So you can understand how changing these might work. And a lot of engineers I've worked with, AI engineers I've worked with, that use these ChatGPTs, rarely ever touch these parameters. And you'd kind of think like, why wouldn't you be doing that? Especially if you're worried about hallucinations, you're worried about what the output looks like. Or imagine you're doing something which is like an idea generator and you've got to create 100 ideas. Well, if the temperature's not high, you're just going to keep getting the same 100 ideas over and over and over and over again. So if you're creating content, you're creating something original, you can use these sliders almost as a way to sort of control that. And again, you won't have access to this unless you use the APIs directly here. And if you use any other model, like even open source models, you'll get similar parameters as well.
What are the default values of these in the API if you don't set them?
It's whatever they come when you load them. I think temperature is usually 1 or 0.5, and the temp P is 1. There's like a simple one that comes off the back of that. Another one I was going to show you all that I forgot is the probability one. So if I turn that on, so I can, well, so you can see here like Lily stumbled, Lily came, Lily heard, Lily saw, Lily spotted, and you can see the predictions. But then you also see that Lily came upon whatever, it's got a higher prediction, but the reason probably why it picked stumbled is because it's not just the probability of that word, but the other probability of the other words and the context in which it sits. So I was meant to show that demo earlier. But you can see these probabilities if you're really interested as well. And again, that's a more advanced sort of...
I have a question.
Okay.
Yeah, good question. So you mentioned about the instructions as well earlier, where you had like a lot of line items.
Yep.
That you do not share any competitor and do this, do that, blah,
Yep.
blah, blah. You have like a long list of instructions. But then on the other side, you also have like this temperature where you are controlling the randomness or
Yep.
the creativity parameter. So in what scenarios?
Alright, I've got to charge up.
In what
Keep talking.
scenarios do people actually rely on temperature versus instructing the model that you do not go over creative with these things? How do you balance these instructions versus temperature or the p-values?
I think the instructions are probably more critical than anything else. So always start with the instructions. No, that's fine, I've got it. The instructions are probably the most critical part. And then afterwards you'll probably tweak the temperature and stuff like that. But if you're working on something and it's obvious that you're doing something creative or something like that, you would probably tweak those to begin with. So it's trial and error. There's no like, you live in here, and that's why they call it prompt engineering. Like you're sitting here, you're writing it, you're changing it, you're tweaking it, going back and forth and back and forth and back and forth until you sort of get the output. Like I can show you my mid-journey in my Discord, hundreds of images till I get the one that I like, because I'm tweaking it and I'm really tuning the words and finding what the quality I'm looking for. So a lot of cases people don't see that. They put 2 sentences in and they're like, it's crap, I'm not going to use it.
So you can give an instruction and say that whenever you are working on my input, do not be over creative, and at the same time you can come here and control the temperature as well.
Yeah.
Is that right?
You can, but sometimes those don't be over creative and stuff. It's still language based. This gives you actual control of how it behaves. It's kind of hard to explain. I would actually recommend just playing with it and testing it. So you can get an account on OpenAI API and just chuck $10 in it and you'll have access to it. You probably won't burn the $10 ever. So, yeah.
Can these parameters be tweaked in the regular base version of ChatGPT
In the UI?
Yeah.
No, not in ChatGPT. These are already in the background. Because remember, it's sitting, the model's already been wrapped around.
Prompt it to change the temperature.
No.
So you use randomness and creativity in the same breath, or they're different? The creativity-
Kind of randomness leads to creativity in a sort of weird way. Yeah. Yeah.
How bad would it be if you asked like UI ChatGPT 3.5, GPT-4 to simulate a higher temperature or a lower temperature versus actually?
I don't think it'll behave. It's just language you're giving it. You're just giving an instruction. Yeah. But you can give it personas. So you can be like, you're an expert at this, or your personality, and it will talk to you in a certain way.
You're extremely creative.
Yeah, that might help, but it's not actually going to change fundamentally how its output's going to be, right? Yeah. And then the other one, I was going to go through a couple of demos. So the first one is like classical natural language processing tasks. So we could do things like, what was I saying? Can I grab an extension cord? Sorry. It's going to get so annoying. You are a sentiment analysis tool, and you'll respond with either positive or negative. So we could do something like that, like classic sentiment analysis. I could say, I love burgers. says it's positive. Perfect. Now you could say something like I love burgers, which says it's positive, right? But then I tried this once and it worked really well, and another time I didn't really save the prompt, so we'll just do it as we go. Positive, negative, or neutral. So say, like that. Should say neutral, yep. But then I'm like, actually, like that's not good enough. I want to get it a little bit more interesting. So we could say something like, respond with a numerical range between -1 and 1, where positive is equal to 1, negative to -1, or neutral, which is 0. So now I can say something like that. It should come back with 0. Y. Well, last time this worked really well. I don't know what it's doing. So you can get it to do like numbers and stuff like that. There you go. I love burgers. Burgers are okay. All right. So you could do things like that. We could also do things like give me emotions, or other sentiment analysis tasks could be, you are a company assistant to route messages to the right department. Use either sales support, whatever, finance, other. So I could say, I need my account changed. Again, this is pretty generic, right? Support. So like you can feed all your email messages through, your Jira tickets through, something like that. You can do something basic. Like if we were to you could build a custom classification using natural language processing, you could do all that. But with this, we can prompt it. We can tell it to give it tools. We can tell it to do other things. And then we can just take that input and we can create an automated workflow around that. So this is what like some of the classic use cases are, summarized and things like that. But, we could build some interesting use cases by doing things like this. Some of the other more interesting things that you could do is actually, I don't know if I have it here. I don't know if I shared it here actually. You are an entity extraction service for chat messages. You will give me a JSON response with people, places, topics. So let's just go to news. For example, something about ASIO and Telstra. Sounds fun. Let's grab that, copy that. It's extracted all the people, the places. You get the idea. You can actually tell it to do like document extraction. So you can tell it to look for certain things, a Jira ticket number or whatever. But it might not know what that thing is, but you can give it examples. So if I was like, Jira tickets look like this in my company, it's usually this many numbers or this many things. And then you can sort of help it sift through things like that. And the reason why I'm showing this example is a lot of times people think of ChatGPT and these LLMs as like these let's create documents, let's solve everything with them. But I think a lot of the power is actually in this like sort of 99% use cases that are very like workflow driven, repetitive process that a human's really good at. But when you have good language comprehension, yeah, you can extract information and build that, but you might not be. So if you're an organization, let's say you're doing fraud investigations, right? And you're looking at letters that are come in and you're checking if they're fraudulent or not. Maybe you can do something like this to do the initial triage and grab the information that you want. And that's actually going to support you in sort of helping do that process. So a lot of this stuff is really good for like understanding huge amounts of data. So one of the projects that I've been working on as just a side project, not as a financial thing, but just for fun, and because I was struggling to learn myself, is field study. And what I'm doing with this one is I'm feeding through hundreds and thousands of research papers every day, and I'm trying to create personalized output by doing the extraction processes that I've shown you, but also try and map the relationship between them. So one of the things you can do is something like this, and if any of you have done any sort of complex data projects, there's these things called graph databases, and essentially all graphs databases do is like create these relationships. Maybe if I Google an example. I'm almost at the end, guys. Sorry, just almost there. A few more minutes. So a graph database example could be something like this, where it's like you've got things like, you know, there's a person and they're a member of this company, and they're part of this club, and there's information. The beauty with graph databases is you can take really complex ideas and turn them into like these relational diagrams and store them in a database format. The beauty with something like this, and why I was doing it with the research papers, is that I can take all the research papers and teach a large language model to create the output to feed into a graph database, so that it starts to map out the different topics and the people and create this like web or this world of all these different ideas together. And I'm not saying like do this, it's just an example. But this is like a more complex prompt that I have, where it's like you're a graph generation assistant. Your task is to meticulously take some high level concepts. You'll respond back in JSON, which is the code. You'll break down larger terms into smaller ideas. You'll ensure the nodes and edges are connected. If you're not, you know, try to do them. You don't make assumptions, you stick to the information provided. And I give it an example, and then I give it the input, and that input there might be a summary of the research paper and some of the information. And then this starts to feed and create this like three-dimensional web. I've got examples, but I'm not going to show that now, but you can start to see like how we can take a really complex problem that a human could easily do, potentially, but if we can force it to understand the language and the concepts, we can get these machines to behave in really strange and weird ways as well. And then the last one is like, you know, I'll give you another example of something which is a little bit different. So if I go to ChatGPT, we'll keep using the playground one. That seems to be working well. You are a helpful assistant. Okay. What's going on? Someone give me some random topic. Could be anything. Dragonflies. Just say that, right? Like in the biological sense, whatever. Dragonflies are insects, nymphs, whatever, all this stuff, right? Please represent this in Mermaid. Now, Mermaid and some of these other things, oh, it's awful. Let's just go ChatGPT. So Mermaid is like a relational thing that you can build charts from, but it's human readable. Like you can read this and you go, okay, A is a dragonfly which is tied to this order or dana or whatever. And the beauty with this is you can go to like tools like Excalibur, which are like drawing tools. You can see these are some of my other things. But then you can import these essentially. I don't know if I've got it right. I've got another tool that does this. Oop. Again, I'm just showing you examples. Wait for it. Is it loading? What's going on? Oh, there you go. So it's built this understanding that there's dragonflies and there's characteristics and things like that. And what I'm trying to explain here is that like you can take a really complex idea and tell it to re-represent it in a completely different way. And this concept's being used, I think it's called Core Explore, Excalibur. Yeah, it's used by engineers quite a bit.
But what about the Cell app? Did you make that?
No, it's someone else's. But it has it in here, but you just got to put your OpenAI key in there and it does the same thing. Sorry, I can't remember the name of this tool, so I'm just jumping on my LinkedIn because I posted about it. I'm not self-promoting, I promise. This is the last demo and then I'm done. Here we go. So this is called Globe Explorer and essentially uses that same concept. And what it does is, well, you can put any topic in, and it generates the topics and the ideas, but lets you sort of like navigate those topics and ideas. So you can, and then it sort of finds images on the internet with graphs. So like you can take a really complex idea. So if I put dragonfly biology in here, you probably get a similar thing, but then you can actually start to like traverse it and go through it. And when they came out, their website was crashing. The whole idea is that with a lot of this stuff that, like, I rarely talk about tools, but the idea is like more how you use these tools. I think a lot of people are focused on like, let's summarize, let's create content, but actually there's the power, because it can understand our natural language comprehension, that we can create such rich experiences on top of them. And yeah, you can throw anything at it. And I use this, a lot of this process for my own learning processes as well. So when working with LLMs, just to wrap this up, know your tools, like flavor of the models. There's different types of models, different types of use cases. Prompting and engineering, keep experimenting. The 1% versus the 99% use cases. The 1% is like your simple summarize this content, create me another image, but there's 99 other million things you could do once you actually start to understand that it's really good at understanding information and re-representing information in a different way, which is essentially how our brains decide things. It's how we decide as humans. So you can think bigger. And then lastly, treat these large language models as Otto, as a 3.5-year-old. Thank you.
Great conversation.
QR code gets you the slides, and there's a little plug in there for me to, if you want to sign up to a newsletter that I'm working on. But otherwise, I'm open to questions as well.
Can you show us the prompt that you used for generating those images?
Which one?
The mid-journey.
Sure.
Because you said you were getting consistent results, so I was just wondering how complex that.
So one of the things that's happening with image,
Yeah.
one of the things that's happening with images now with Midjourney, they have something known as a style reference. I don't want to show it on the recording, but what you can do is you can feed in a lot of images as reference images for style, and you can actually say, I want you to weight this by 50% or this by 20% and things like that. So you can use those as like to ground the model in a certain visual sort of way, aesthetic, and then you just layer your prompts on top of that as you would normally. Another really interesting one, if you're looking at images and you're not sure how to prompt, is, and I was going to do this live, but I'm not going to, I don't think, I haven't tested it, so I don't want to do it, but go on like Disney Plus, Hulu, Netflix, whatever it is, go on a movie that you like and a scene that you like the look of, turn on closed captions, and you'll see these massive long closed captions that really explain well what's happening in the scene with like very prescriptive language. Copy that, whack that in Midjourney, and you'd be surprised at the results. Because we're not really good at using certain vocabulary to explain the visual of what we're trying to look for. But when you use things like closed captions, they're really good at explaining an actual scene in like really good, like simple to understand English. So that's like another really good method that you can use to get like really good consistent visual output.
Can you show me an example of how you're using your site exactly, like it's
In what sense?
what you've been putting and what you've been outputting for this?
So there was that one, and I'm happy to send that if you want it. There's this one here. So that's the graph one that I'm using as an example. Like it's quite complex, but it's doing my graphs. A lot of my prompts are not like creative, and if they are, I'm using it for my personal stuff, so I don't feel comfortable showing it. But like, you can grab me afterwards, I'll show you some stuff, but I'm not going to put it up on the big screen. But like they're pretty long prompts to like help break down ideas. I've got one for like my social media where I've actually tuned the words, like which words to use, style to use, examples to use, to help me like create the content for me. So I've used it for some of my content, but again, I'm still curating most of it as well. I'll start there.
So what's the difference so far between ChatGPT and, let's say, AWS Bedrock?
Yeah.
Is ChatGPT much more advanced, or are you specializing in some certain areas?
Yeah, so at the moment, if you think about a really good general model with high accuracy, yes, it's ChatGPT. But as I mentioned, there's other factors here as well. There's things like human bias. for example, Claude has been trained on another step which actually makes it better for like bias related issues. Different data sets are used, so some of these might perform differently in certain scenarios like multilingual and things like that. So there's no like, everyone will say like, oh, the accuracy score is this, but actually you go to use it and it's not the case. The best thing you can do, because a lot of these problems are quite open-ended, the way they evaluate these models is through like a set of like really well-defined prompts and examples, and they're not going to cover 100% of use cases, right? So the best thing I would recommend for people is to test it. And cost comes in, speed is another issue as well, like GPT-4 and Gemini. Like for example, Gemini 1.5, which is the new one, which has yet to be released. A lot of people saying like it can do potentially amazing output, but then I've heard people say the opposite as well. But then at the same time, speed, cost, like there's a lot of factors, so there's no like one answer for it all. But privacy, bias, and it also depends on like what you're trying to achieve. If you're just trying to summarize some text in English, you can use any model for that nowadays, right? Are you trying to create some really deep, creative, like create a character? Or again, it depends on your use case. And in a lot of cases, I recommend to people use different models for different things. So use the cheapest model, the fastest model, where you can, and then work your way up as well. Yeah. Questions back?
You mentioned about context. How do you provide user context to the model and ask the model to pay more attention to that topic?
So how do you provide the context? And so in terms of context, that's the prompting example that I showed you, where you give it, if you give it all those things, it sort of forces it to behave in a certain way. And if you want it to pay attention to certain things, just say, pay attention to X, Y, and Z as a step. Another method is what we call negative prompting. If there's things that you don't want it to do, just tell it, don't do this, don't say this, don't use these words. Like spell them out, same as OpenAI did with their system prompt. They've got like 100 list of laundry things that they don't want you to do, and they've told this in the system prompt. So you might know what you want, but then you also know what you don't want, and that's also another way that you can prompt it as well, like things that I don't want you to do as well. Previous activities? Yeah, if that's relevant to the context, 100%. Yeah. I don't quite know the use case, but you can come grab me afterwards as well.
In terms of development speed, I looked at Sora and was blown away. Obviously,
Yep.
it's not there at the moment. But say, for example, lip syncing and things like that,
Mm-hmm.
would that be, say, 12 months ago? I know you don't have a crystal ball in front of you, but 6, 12 months ago?
In July?
It will be.
Yes.
Or sort of.
Yeah.
But then in terms of the next stage, I mean, what's the rate of development that you see? I mean, in 12 months' time, will things be totally different? Or will they be just a slight extension of what we have now?
It's hard to say, honestly. I think the big thing is that this push towards, essentially, like to give you a crystal ball of like where I'm seeing this going, Sora and Gemma, which is another one from Google, which is designed to create digital worlds. One of the tricks that people missed what they were doing with Sora was they're not only generating video, they've actually trained it on digital worlds. So they've trained it to play Minecraft. Now you might think like, what has that got to do with anything? But it's creating three-dimensional worlds that are like almost physically correct. And the thinking behind that is they want these models essentially to be able to model worlds, like simulate a world, because then they can teach other models to better understand and behave in these worlds. So it's this idea of creating humanoid robots, for example. How does a humanoid robot work around, observe the world around it? They got to create data for that to happen. So essentially this process is allowing it to sort of synthesize like millions of different scenarios and allow these machines to sort of play through those.
So synthetic data.
Correct, yeah. Any other questions, Frank?
Yeah, can you throw some light on the model refinement? Like, how do you fine tune your model? And can there be large language models present to form one big LLM? Like, there are subsets of LLMs.
Yeah.
So can you throw some light on this?
So when it comes to fine tuning, so one of the things you can do is you can go, hey, OpenAI, money's not a problem. Can you go fine tune a model for me? So they provide a service, and essentially you give them your data and a lot of money, and they'll create a version of ChatGPT for you, right? That's been fine tuned. Or, like, I've not really seen anyone do that because it's stupidly expensive. Or you get one of these open source models, which are actually pretty good, and you teach it to do a task. Now, the beauty here is because you're training this model to do your task, it will actually surpass GPT-4 model performance because it's getting really good at solving your one particular problem, right? And the way you can do that is by grabbing one of these large language models and an AI engineer and a bit of hardware. And there's processes you can follow. But now we're starting to see tools now being made available by Azure, AWS, that it's going to start to make these things a bit more easier. Give me your data, pick your model, this is how much it's going to cost. Let's go train and fine tune a model. And the way this fine tuning process works, if you're ever interested in a real simple sense, it's like the models like this, they like increase the brain capacity a little bit more, and then they just tune that extra bit on the outside. So they don't tune the whole model, that's why it's cheap. You're taking the extra model and you're gluing this extra bit on top.
So I can customize it and personalize it according to my needs and requirements. For example, if I come from a retail industry, I can feed in data and say that please fine tune it for retail industry and
so what happens with the fine-tuning process is you're feeding it lots of input, output. So we might give it lots of input text, and the output could be positive, negative, positive, negative, positive, negative. Now you've fine-tuned a sentiment analysis model. So they've created like a medical one. They've given it lots of medical data and output a diagnosis. So now whenever you write to this medical LLM, all you're getting output is a diagnosis response, right? So you have to actually have this data. And a lot of enterprises actually like struggling because they think, oh, we'll just fine tune a model. Okay, where are you going to get all this data from? I don't know. They're lost, right? So some companies have gone as far as like actually forcing people to do this whole question answer. Like, so Databricks did this when they trained to fine tune, created a public model. The whole company was incentivized to sit there and write prompts and answers and like in-depth answers. So they had a curated data set so they could actually create a large language model. So a lot of it comes back to data, you know, that's the problem. Like if you want to fine tune it, you want to do legal, you want to do this, but you need the actual information. So organizations that have a lot of this data would be like Bloomberg or law firms and stuff are now starting to explore this because the models don't have this data. They don't want to give their data to these companies. So they're trying to find that sweet spot because their data is, these companies want their data so they can build these legal models and build these financial versions of these models as well. But there's nothing stopping organizations from creating small models that do one job and do that one job really well. Yeah.
Thank you. And isn't that the past data point, what you just mentioned, the legal organization? For example, they will take their old cases and then say, this is positive, this is negative, this is the way to think.
Correct.
Is that what they're doing?
Yeah. But someone needs to teach this thing. Like, yeah, that's the hard thing.
Okay.
There's a little bit more trickiness when it comes to medicine and law because it needs deeper context, and sometimes these language models don't have the understanding of all the documents.
Yeah.
So there's some other processes you have to do on top to like extract information from other documents, build context, feed the context into the prompt.
Right.
So things like RAG is one of those aspects of like where you're grabbing data from different documents and gluing them together into the prompt. Yeah.
My friends are about so how can we access the slides and recordings after?
The QR code.
It's QR code. I'll email it.
Yeah, the thing I'm curious about is so things like the first ChatGPT things we got to play with. There was like a cutoff point where
the data
came from.
Yeah.
And so you could be sure at that point that there wasn't very much AI generated data for it to train itself on.
Yeah.
But the amount of AI generated data out there that'll be taken back into models and to train them.
Yeah.
I mean, I think the internet was sort of drinking its own bathwater before this stuff came along.
Yeah.
So how do you see that progressing? How do they avoid that when they're training the models from now on? From this time last year on, I guess. And is there much evidence of how that's influencing models now?
So the training process, usually the reason why they don't train is because it's expensive to retrain these models at this scale. So that's why you don't see it very often. I'm going to answer this in a few parts. There is some changes. So perplexity is one. I'll just quickly grab it up on my screen. Perplexity. And what they've done is they've taken an open source model and created a layer on top of that where they're feeding in news and other current information. You can ask it something, so I can say, what happened in Sydney? I don't know, I'm going to make this up. I haven't used this in a while. but it will use current information, as current as it can be based on like live information. So sort of they've built a layer to sort of mangle that together with a large language model to create like a new version of a search engine essentially. So the language part obviously still has to be trained once in a while so it can understand deep concepts and brands and other things like that. But from like a freshness of information, that's how they've solved that. But it doesn't entirely solve the problem. The next point that you mentioned was this idea, I think it's called Ouroboros, which is the snake that eats its own tail, essentially, which is what the fear is it's going to start happening now with these large language models, because if they keep training it off the same data, and now half the internet and social media is full of AI-generated content, is it going to keep swallowing its own content? And so some of the researchers have been testing what happens when these models are trained on its own data, and surprise, surprise, it gets worse to a point where it's just completely terrible. So what's happening now is there's this massive push for deep human-created content, and it's actually like increasing the value of creative content that it's been like vetted and verified. So book publishers, newspapers, so that's why all this like New York Times versus OpenAI is a big sort of case, because a lot of that rich human vetted created content has got value because they'll continue to produce that human vetted created content. Does that make sense?
Yeah, it's like when there's a new genre of style of music pops up, and there'll be a few examples of it, and then it becomes fashionable, and then there are a lot of, once you get enough bad examples to be able to recognize the good examples, then people go, oh yeah, I listened to them before they were cool, you know, and so I guess that sort of creates, there's no scale for looking at something that's completely new. You have to have good examples and shitty examples to measure it.
But can you detect the bad example?